Well, hello everybody, I'm back, and as you can see, I'm inside the bonus quiz for 3.8 demanding quiz, and that the first question itself has two parts here and deals with the idea of total profit function. The second problem deals with simply one page in the entire section, and basically that page is the foundation of economic theory, supply and demand curves, and an idea called an equilibrium point. So we'll talk about that a little more extensively than we will this first problem. Now, here is the template for the derivation of a profit function from revenue and costs. Function notation, it looks like this. Now, C of X represents the cost of producing X widgets. So it's money going out from a firm. And R of X, revenue, represents the amount of money you make from selling X widgets. So this is incoming and this is outgoing, and it makes sense that when you subtract those two, you would get the total profit. This first part, they're asking us to find the total profit function, is really a substitution problem. We're going to substitute in the rule for R of X and the rule for C of X and simplify. When we do that, we have to be careful. There's a moment when things can go awry. First substitution is easy. R of X is equal to this. And then it says subtract all of the cost function. So I have minus parentheses here, and you know that that's a sign changer. When we do that, we end up with this. Notice that the plus 500,000 now becomes a minus 500,000. And we have like terms here. We are driving for simplest form, so we combine them, and there is our profit function. That is indeed represented over here as answer B. But check out answer A. It's very similar, except for the sign here. And MathXL is doing the same thing I do on my multiple choice exams. It's giving you a challenge to prove that you really understand the techniques involved here, that you need to subtract the entire cost function. If you don't have these minus parentheses, you're going to end up with a positive 500,000. As for the second part, go back to the idea that we have a system of equations. We have a line here. Notice the slope is 25, and we have a line here. Notice the slope is 75, and because the slopes are different, we know that those lines are going to intersect. If you want to game the system, whenever you have two lines and they're asking you for a particular point, they're almost always asking you for the intersection point. You might not see that the left sides here are in fact the same. So I could rewrite this like this. The left-hand side is really just money. We really do have a system of equations in two variables. In this case, I have x and m, and we want to know where the break-even point is. That is when the costs and the revenue are the same, and there is no profit. All I need to do really is to solve this system. And so I'm just going to replace money down here by what it's equal to up here. Can we solve that? And we've done it many times. Solving for x, I get x is equal to 10,000. So that's the quantity of widgets you need to make for there to be no profit. You make one more, you're going to have a profit. You make one less, you're going to have a loss. So it's the break-even point. And again, it's an ordered pair, so we need to follow through. We know there's 10,000 widgets. Well, what's going to be the amount of money involved in it? And when you do that, you get an ordered pair. That is the answer to problem 1. Let me go ahead and tell the machine I want B, $10,000 and $75,000. And so let's go on to the next problem here.